Good. Thanks. Alright, hi, I'm McGee-Pasceri, and this is my speech and process on HVAC systems. Right now, you're probably sitting in your home, an office, a classroom, or some type of building. Think to yourself, are you comfortable? More than likely, the answer is yes. The temperature is just right, there's no humidity in the air, and you are breathing easy and naturally. The conditions inside the building may be drastically different than the outside conditions. Outside, especially now in the summer, could be hot and humid. How are our homes so comfortable and conditions so different from outside? The answer is obvious and something that most of us more than likely take for granted every day: HVAC systems. Heating, ventilation, and air conditioning is an integral part of our everyday life, whether it be heating our homes in the winter or keeping us cool in the summer. HVAC systems work every day in order to keep us comfortable. In addition to keeping us comfortable, proper building conditions have been proven to increase productivity and alertness in the workplace. HVAC systems help us sleep at night by adjusting the conditions in our home to the optimal temperatures for our bodies to rest. HVAC systems are truly critical in today's society, but do you know how it works? There are many complexities and various applications of HVAC systems depending on a multitude of factors. But today I would like to discuss with you one major component of HVAC systems that is in almost every system: the refrigeration cycle. Before going into the refrigeration cycle, it is crucial to understand the basic principles behind heat transfer. There are 3 laws that govern the transfer of heat, and they are as follows. 1. Heat energy cannot be created or destroyed. 2. Heat always flows from a substance of higher temperature to a substance of lower temperature. And 3. Heat can be transferred from one substance to another. Heat transfer is typically measured in BTUs, or British thermal units. A BTU is defined as the quantity of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. However, when a substance goes through a phase change, it takes significantly more BTUs in order to complete the phase change. This concept of heat transfer between phases is crucial, or is a key principle in the refrigeration cycle, and thus must be mentioned. One other important point to note is that for this discussion, water will be considered the main refrigerant in the system. There are several refrigerants such as 134A and R411 that are also very common in the refrigeration cycle. The refrigeration cycle consists of 5 major components: a pump, evaporator, compressor, condenser, and expansion device. For the sake of convenience, we shall start the refrigeration cycle at the evaporator. At the inlet of the evaporator, the refrigerant, in this case water, enters as a mixture of liquid and vapor. The mixture is mostly water with only small vapor pores. Warm air, either outdoor air or a mixture of outdoor air and return supply air, then flows across the thin tubes in which the mostly liquid water is held. The warm outside air transfers its heat to the cooler liquid water through the tubes, thus causing the air to cool and the water to boil. Now vapor air leaves the evaporator and is drawn into the compressor through the suction tube. The role of the compressor is to raise the pressure and temperature of the vapor water so it can reject heat to other fluid, such as ambient air or water. A reciprocating compressor is commonly found in the refrigeration cycle. When the compressor draws the vapor through the suction tube by using a rotating hinge, much like a piston. When the piston drops down, it draws vapor from the suction tube into the compressor. When the vapor is in the compressor, a latch closes, thus not allowing any more vapor to enter. Once the vapor is in the compressor, the latch pushes up and increases the pressure of the vapor. Finally, an exit latch opens, allowing the now high temperature vapor to leave the compressor and flow through the discharge line to the condenser. The condenser acts as a heat exchanger, as it rejects the heat of the water to another medium, such as ambient air or water. As the high pressure, high volume vapor flows through the tubes of the condenser, it rejects heat to an alternate medium. An air-cooled condenser is one on which the vapor refrigerant rejects heat to ambient air, and a water-cooled condenser is one in which the vapor refrigerant rejects heat to a water source. In both cases, as the heat of the vapor refrigerant is reduced, it begins to condense back into a liquid. The refrigerant then leaves the condenser as a high pressure liquid. This liquid travels through the cleverly named liquid line down to the expansion device. The purpose of this expansion device is to drop the pressure of the liquid in order to match the pressure in the evaporator. That's fine.
It's from here.
It's okay. Sorry about that. When the high pressure liquid flows through the expansion device, a large pressure drop in the water occurs. The pressure drop reduces not only the pressure of the refrigerant, but also the temperature. This low pressure, low temperature water then flows back into the evaporator, and the cycle repeats. I actually may have missed a part right there that I want to re-explain for you guys. So basically the last part of the refrigeration cycle is the expansion device, and that creates a really big pressure drop, which is going to drop the pressure of the liquid and also drop the temperature, and then that's going to go back into the evaporator and the process is going to restart. Air conditioning is essential in keeping us cool and comfortable every day. It takes heat and humidity out of the air, and day in and day out delivers us fresh and pleasant air. This air makes us more alert and productive at work and allows us to sleep comfortably at night. This air makes us more alert and productive at work and allows us to, oh, sorry, I just read that. The refrigeration cycle is the part of the air conditioning system that takes the heat and humidity out of the air, and thus allowing us to be comfortable no matter how hot or humid the air is outside. The refrigeration cycle exploits the additional heat that must be generated during a phase change, pressure drops, and associated temperature changes in order to effectively cool and dehumidify supply air to a space. The next time you're sitting at your desk, in your home, or lying in your bed, you can thank Mr. Oliver Evans, the inventor of the refrigeration cycle, for keeping you cool and comfortable.